What is up? So finally got this freaking engine block back from the machine shop. Sleeve came out really nice. So I have it all masked off. I'm gonna shoot it with some epoxy and then some gloss black, you know, as I kind of usually do. And then I get to finally start getting all the stuff off the tables here, you know, crank and bottom end in it. And then I gotta put the heads on this thing, new AFR heads, and do some port matching with the intake. But there's a long road to go before I get to that point. So I'm gonna keep you guys updated as I put this back together, but I'm gonna shoot some primer and then some gloss black on here. Should come out really nice. Got the epoxy laid down, so next step is obviously the gloss black. But this stuff, you know, basically has a really good adhesion to the, you know, bare metal surface, and makes it so you know, get a good bond instead of just putting urethane on there. The urethane directly would probably work, but people online recommended epoxy, so that's what I did. Got this freaking bad boy painted. So now I'm gonna take the masking off of here. You know, obviously not the most exciting process, and I'll show you guys the sleeve. So it's number 7. Give me a few minutes, I'll get that masking off, and you'll see the guy did a really excellent job on the sleeve, so definitely happy with how it came out. Black paint looks really nice on there, so you can see the block is nice and clean. He hot tanked it, which basically gets all the oily residue off of here, and I'll show you where the sleeve is at. So I'm not sure if I showed you guys, but there was a crack in cylinder number 7 here, so you can barely see it. It's a thin wall sleeve, but if you look really close, there's a sleeve in here, and you know, that obviously cleaned up the cylinder wall that had the little crack in it, so it looks really nice. You can kind of see it right down at the bottom where there's kind of a change in the metallurgy, but super nice, and all the other cylinders have been ball honed, so pretty much ready to put together. So what I'm going to work on now is flip this thing back over, and I'm going to start putting in you know, these main studs. So when I did put this together, I got main studs, so I just need to screw them in, and you just tighten them down kind of by hand. Maybe just use a 1/4" wrench, just tighten them down lightly, and then I'll put all the bearings in there, obviously with some assembly lube, and then set the crank in here. Obviously I have to put this lower part of the rear main seal in, then I can set the crank and pretty much tighten this down. So it's already been line honed and everything. It really didn't have any miles on it. I'd say maybe 5,000 miles, so everything is in pretty great shape still. Bearings look fine, so I'm gonna get to work on that, and once I get a little further along, maybe after everything's torqued down, I'll grab the camera and show you guys. So one of our favorite moments are here with the old big blocks. So I have everything set up, all the bearings in, all the main studs are in. I'm just tightened down, you know, not too tight. And then I put some assembly lube on all the bearings. And then for this rear main seal, basically I scanned a bunch of forums, and they say obviously to clock it 3/8 per the instructions, and also put just a little bit of silicone right on where the two halves meet. So fingers crossed it doesn't leak. I think it's inherently kind of a bad design having 2 seals separately instead of a one piece. If you look at like a more modern engine like an LS, it's basically just one seal that goes over you know, the back of the crankshaft, which is obviously harder to change if you wanted to keep the engine and transmission in the block or in the car, but I think it just is going to last longer. But if it drops just a little bit, it was pretty bad last time. If it just drops a little bit, I'll be happy. So I'm gonna kind of, you know, get everything squared up here with my other table, and then I'll drop the crank in there. So this is one of those situations where an abundance of caution should be used. Obviously those main studs, you know, they have some threads on them, and you don't want to hit any of the journals against them, and obviously make sure to have some lube of some sort on the bearings themselves. I used assembly lube. I think it'll last a little longer as I go through and spin the engine for the push rods, and also to degree the cam and do all this work. So assembly lube is a good option. And also when you're doing this, make sure you're aligning it with the mains and not the rod journals. It can be kind of an optical illusion, but once you lower it in there, you'll kind of see where it needs to go. And then to set your thrust, one thing people recommend is to hit the back and front of the crank, and that'll kind of set your thrust bearing. So got all the main caps on here. Everything went in super easy. But what I've been doing is adding this ultra torque assembly lube to these threads, because when you do torque down a fastener, you basically want the friction to be the correct per their specs. So ARP recommends coating the threads with this, and same with the washers and the surface under the washers. So when you do go to torque it down, it's actually 110 foot-pounds, and that's not on the fastener, and it's not caused by basically the friction. So I've been taking a little time and using a little paintbrush and coating these, and then I can put the nuts on them, then I can torque it all down. One thing I think I should mention is, you can't really just switch over directly from main bolts to main studs. So if you are wanting to go to main studs, you're going to have to get the engine line honed, which is where they run a hone through all the basically main caps to make sure they're all concentric with one another. So don't just switch over, make sure to get it line honed. So some machine work is required if you want to run main studs. As you can see, I got it all torqued down here. So my strategy was to start in the middle, make sure to do the center two first, and then move to the outer ones and kind of go this way. I don't know if the order that you do it really matters that much. And then I also recommend using some like a paint pen, just to make sure that you keep track of all the ones that have been torqued down. And I did it in 3 increments. So with the main studs, it's 110 foot-pounds, and they recommend splitting it in 3 increments. I didn't show the first 2, I just showed that final torque, but that would be like 33 or 36, 73, and then 110. So this is all done, freaking looking good. And now I'm probably gonna let the paint dry and then flip this thing over, or I'll check the end play of the crank, and then once I confirm that's good, then I'll flip it over and start getting my rods and pistons ready to go in there. Now that I have the crankshaft in there, time to gap the piston rings. So I got a matching set as to what was in there, and what I've been doing is I got 1 piston in there already. Obviously put this in the bore, and I 3D printed a little piston squaring device. So this kind of goes on top and gets the piston ring nice and square in there, and it's basically right at the top of the bore where the piston hasn't been wearing. So you want to make sure that it's kind of worst case scenario where there's no material that's been removed from the bore. So I've been putting it in there, and then for a racing application, I believe you multiply by the bore times 0.0055 to get your piston ring gap for the top ring. And then the second one I think is a little tighter. I think the top might be 0.0053, second ring is 0.055, whichever one makes the second ring tighter. So I've been putting that in there, coming out really good. On the other side, got that one done. So obviously I have quite a few to do, and you don't need to gap the oil control rings. And then orienting them, I kind of just came up with a little way to orient them, looking like this. So top ring goes here, and then second one is 90 degrees, bottom oil ring, top oil ring, and the expander goes on the thrust side. So I'm gonna keep working on this. I might make a little time lapse. It's kind of a tedious process, but you guys can kind of see what I'm doing. time lapse, you can see, you basically go back and forth and, file it a little bit, and then put the piston ring back in here with your handy dandy frickin' squaring tool. So I use this just to square it up. It's definitely kind of a rough 3D print, but it works. And then check it with the feeler gauge, and then basically you want a little resistance once you get it to the right gap. And then I sand the edges just a hair, just so there's not a lot of burrs on there or anything. And then clean it all up. This is it was from a running engine, so I kind of got all the oil off of them, and then slide it in there. And I really recommend, if you do have kind of an overboard engine, you can get these that are basically to the specific size. It's a lot better than the ones that kind of constrict. Makes it super easy. It slides basically right in there. Once you get the skirt in there, then it kind of just goes right in. So super nice. I got this last set, and I am kind of interested to see how it will be with this. This is actually the sleeve cylinder. You can hardly see it, but we'll see what this one looks like, and then we'll be freaking done with the bottom end. And when you're using this ring filer, basically you put the ring on here like this. I kind of did it in a different way. I was putting it on this side. This is the way you do it, because it kind of allows you to square it up and push against this right here, and gives you the capability to really kind of put it where you want. So I don't think it's the end of the world if they're not completely straight, but half of them will be. So I'm gonna get this done, and then we'll catch up once I get all the rod bolts tightened down. Make sure when you're putting this in here, obviously you don't take the crank. So just goes down, got the bearing in there, and some assembly lube. Obviously this no longer needed once the piston's in there. Just kind of lining it up with the crank down here. And now, if I flip this over, you guys can see I basically got right here. So this is the one I just installed. You want to make sure when you're putting this on, you don't let the bolts actually pull it down, and you put it on here and pound it on there with the hammer, and then use the bolts for that final setup. And then on these bolts, basically to get the correct bolt torque, similar to the main caps I think I mentioned, you got to make sure to use this moly lube on there, on both the threads and underneath the head, so it has the correct I think kind of coefficient of friction, so you get the correct 63 foot-pounds on these. So that's going to be the next step. I still got to kind of space these rods out and make sure I have a good gap between them before I torque them down. But that'll be a project for tomorrow. What I've been working on is checking this connecting rod side clearance. Basically, you check the gap in between them. It doesn't sound like it's too critical, but you definitely want to make sure you have a little bit of a gap there. So I was using the 0.25 feeler gauge, and the only one that's a little tight is this one, but it's like 0.22, which should be all right. So just get that guy in there and just make sure they kind of all have some clearance in between them. Make sure so it's not too tight. And now that I got it all checked down here, I'm going to start torquing these rod bolts. Use my paint pen when they're all tightened up. And same thing with these ones. You got to use the moly lube on the threads and also under the head of the bolt. And then these go to 63 foot-pounds. So that's current initiative. And then I'm going to put the oil pump on, and then I'll probably call this video good. So for those of you that have never seen one of these kind of taken apart, it's just a set of gears that go together, and I am noticing maybe just a little bit of junk in there. You know, I just wanted to make sure, given that there was a bolt that went into the engine, it's over there, that there's no stuff in here. I'll just use some brake cleaner, some compressed air, and get everything out of here, put the cap back on, and we should be good to go to mount this up. So pretty cool. So those just spin, and obviously you know, create your oil pressure and push it out through there. So in through here, and then out through this hole, obviously to the main bearings and everything. So I'm gonna get this cleaned up, put it back together, and then put it on. Got it back together and got it installed. So 55 foot-pounds on that rear bolt, and you know, everything looks really nice. Everything's marked with paint. Gotta do one more marking here for that, you know, obviously this oil pump stud. But other than that, we are all good. So you guys saw, I believe I showed you the pistons and everything, but if not, go over to this side. Looks really nice with all the pistons in there. Everything's all honed, so it should be pretty fresh. You know, we got to break in the rings and everything, but it should be good. And I'm gonna have around 10.5 to 1 compression with the new heads that I got. I used to have 11 to 1, but I think 10.5 will be kind of the happy medium there. So in the next video, I'll be putting in the cam and putting on the heads, waiting on some head studs. And then another thing I got to figure out is how to port match the intake. So never done that before, but you know, good opportunity to learn. So appreciate you guys watching, and we will see you in the next one. Hey, thanks for stopping in at the Phantom Motorsports YouTube channel. If you like what you saw, give me a big thumbs up, and hopefully you're leaving with a bigger smile than you came in with.